This is question 7 on the N25 mark paper 1. You're given the position vectors of A and B. You're given M is a midpoint of OA and C is a point on MB such that this is true. As always, for a vectors question, I would highly recommend sketching the problem. So if let this be O, let's say this is point A, that is point B. M is the midpoint of OA. C lies on MB such that CB is equal to MC. This means that CB is longer than MC. That means that C should be somewhere over here. And you're asked to show that this is true. So, OC is equal to OM plus MC. From the diagram, we can clearly see that MC is a third of MB. We can also see that MB is OB minus OM. M is the midpoint of OA. OB is equal to B. And there we go, a half of A plus a half of B. Easy 3 marks. In part B, you're asked to find the exact value of B dot C. C is a third of A plus a third of B. We can factor the third out of our expression. Using properties of dot product, we can expand this sum because it is distributive. So B dot A plus B is B dot A plus B dot B. B dot A, using the definition of the dot product, B dot A is equal to the magnitude of B times the magnitude of A times the angle between the two, which were given to be 45. B dot B, you can use the same definition, or if you've done this kind of question more than 3 times, you would know that this is simply the magnitude of B squared. Magnitude of B is 6, magnitude of A is 5. 6 times 5. Cos of 45, that's root 2 by 2. Magnitude of B is 6 and I get squared. And you should get 5 root 2 plus 12 as the final answer. A pretty straightforward vectors question. Question 8. This question is on proving that a function is invertible for all real values of x. As I have hinted earlier, to show that f is invertible for all x, you should show that f is monotonic on that interval. It basically means that it is only increasing or only decreasing on the interval. To do this, we have to consider the sign of f prime. So let's differentiate f. Even if you have no bloody clue what to do, just writing down the derivative will get you a mark or 2. Now, we want to show that this guy is strictly positive. How do we do that? To show this is strictly positive, we need to have something squared, right? Because we know that something squared is always greater or equal to 0. So let's complete the square for this. This term is now 3 times x minus 1 squared. 6 minus 3, 2 cos 2x. Cos of 2x is always between -1 and 1 for all real x. This part is optional, but I highly recommend. Therefore, 2 cos of 2x is between -2 and 2. That means 3 plus 2 cos 2x is between 3 times x minus 1 squared is greater or equal to 0. Therefore, if we add everything, we get an expression that is always between 1 and 5, which is always positive. That means that f is monotonically increasing for all real x. That means that f is invertible for all real x. You can use a diagram to support your answer. You don't have to. Examiners know what you're trying to prove. They are teachers after all. They know what they're doing. So this is the end of question 8. Question 9. This is probably my favorite question of the paper. This is a counting question. And as with counting, it is really hit or miss. You either get it or you don't. If counting is not your strong suit, I repeat, please move on. Even though it's worth 8 marks, you can still get a 7 with 102. It's alright. Skip it, move on, and come back to it afterwards. Write down an expression or two, hoping you will get 1 or 2 PT marks. If you're still here, let's get going. So we have a club with N heavyweight, 5 middleweight, and 3 lightweight. So a total of N plus 8 players. We want to make a team of 7, including 1 heavyweight, 2 middleweight, and 2 lightweight, and 2 reserves from any category. So let's do it one part at a time. How many heavy players do we have? N. How many do we need? 1. How many ways can we choose 1 from N? N chooses 1, or just N. Middleweights. How many do we have? 5. How many do we need? 2. How many ways can we choose 2 from 5? 5 chooses 2. Lightweight. How many do we have? 3. How many do we need? 2. How many ways can we choose? 3 chooses 2. Reserves. How many do we have? We have a total of N plus 8. We have picked 1, 3, 5. We have picked 5 people. So we have N plus 3 to be selected. How many do we need? 2. How many ways can we choose 2 from N plus 3? N plus 3 chooses 2. A total of 600 such teams can be made. Therefore, if we multiply all 4 numbers, we would get 600. This is the end of the counting part. This is the start of the algebra part. N chooses 1 is equal to N. 5 chooses 2 is equal to 10. 3 chooses 3. 3 chooses 2 is equal to 3. N plus 3 chooses 2, that is N plus 3 divided by N plus 3 minus 2 factorial times 2 factorial. Okay, N times 10 times 3. N plus 3 factorial divided by n plus 1 factorial. Let's roll out one term at a time. So n plus 3 factorial is equal to n plus 3 times n plus 2 times n plus 1 factorial. We stop here because downstairs we have n plus 1 factorial and 2 factorial here. Therefore, n times n plus 3 times n plus 2 is equal to 600 times 2 divided by 10 times 3. And now it is just algebra. We know that n is the number of heavyweight players, so n has to be a positive integer. Because it is on paper 1, that means that your value of n has to be relatively small. So let's test n equals to 1. If n is equal to 1, you would get 1 plus 5 plus 6 minus 40. This is negative 28, not equal to 0, therefore not true. If n is equal to 2, we would get 8 plus 20 plus 12 minus 40. This is indeed equal to 0, therefore it is a root. So if n equals to 2 is a root, we can then factorize this cubic completely. Minus 2n squared plus 7n squared minus 14n plus 20n minus 40 is equal to 0. N is equal to 2, or this guy is equal to 0. However, a quick check of our discriminant would reveal that this term, the discriminant, is negative. Therefore, it has no real roots. Therefore, this is the only solution. And we can stop our answer right here.